Good morning and welcome to Neurology. So, today we'll be talking about the thalamus. Now, before we start, a funny thing happened. Must be some gentleman. matlab he's so far sighted that even before starting of the lecture, he has put the dislike button. So, it's like a request to him, कि boss, if you want to do the dislike, do it after the lecture is over, right? And then there are some very special mails, right, sent by such people. So maybe once we complete the neurology, let's rethink about how we really plan for further medical training, right? We'll rethink, because say it's like I'm not demanding anything, and such mails and such dislike buttons means even without before the lecture. Well, that is very good. Matlab he must be a good Jyotish, right? So all the best to him. Let's start with our today's session, right? Now, let's say this is cerebrum, right? And when we divide the cerebrum, we into two parts, right? This is absolute basics, because that's the base of even the next lecture. One, what is called as the telencephalon, right? Telencephalon. By the end of today's session, you'll be having complete idea about all the circuits of the brain. You'll know that this is how the brain is arranged, right? And the second is diencephalon, right? Diencephalon. So what telencephalon is? Telencephalon is the outer structure. So that is cerebral cortex. ठीक? But to that, just add one more thing. A super interesting and very important topic, and that is the basal ganglia. Basal ganglia, right? A very important topic. So this is like outer. Graphically, today we'll start with the dissection, and layer by layer we'll keep on removing these structures so that you get the complete idea. When it comes to diencephalon, simply speaking, the brain around third ventricle, right? So you know the ventricles, right? There were lateral ventricles, right? Then in between third ventricle, then it opens into fourth ventricle. So everything around the third ventricle, it is what we'll be discussing today. So what's that? That would be thalamus, right? This is thalamus. But things don't end at the level of thalamus. Thalamus would be the main topic for today. But then there would be epithalamus. Yes, we'll be watching all the components. In the title, I have given thalamus, but yes, we'll be discussing all of them. Then subthalamus and the hypothalamus, right? Hypothalamus. When it comes to thalamus, simply speaking, this is the largest part of the diencephalon, right? It is largest. And important, it is paired. So it means it is on the both the sides, right and left, right? And there are so many nuclei. It is a relay center. Today we'll be watching even the MRI of say thalamic infarct, what really happens, right? And immediately you'll come to know that yes, these are the sign symptoms which can develop when there is infarct. You'll also be knowing about thalamic pain, why it occurs, right? So all those things. So but basically remember this is like a relay center. Relay center between, this is the brain stem, right? Brain stem which was having midbrain, pons, medulla oblongata, and then comes the spinal cord. So everything, all the things in the form of ascending track, means the sensations which are getting carried by the entire body coming up, right? They all are relaying into the thalamus, and then from thalamus, right, it will be sent to cerebral cortex, right? So now the thing is, this relay center or the thalamus, it is a very fine control, right? It is a superb control. That's what we'll be watching, that how it really happens. What are the nuclei? Talking about epithalamus, right? Talking about epithalamus. It's a dorsal part, but there will be so many important areas. Now see, some of the areas you'll know immediately. Pineal gland, right? Now if you have practiced on those figures, right, in the previous sessions, immediately you'll say, yes, that pineal gland, which is meant for that circadian rhythm, right? Then there was habenular commissure, correct? Because there is habenular nuclei. So habenular commissure is like talking to opposite habenular nuclei, and that's how they both talk to each other, right? So habenular nuclei. Then there was posterior commissure, right? Posterior commissure. There was anterior commissure, posterior commissure, habenular commissure, and the largest one is corpus callosum, right? So all these are plus the stria medullaris, right? Just keep in mind, as we'll look at it as it comes, right? These are all part of epithalamus, right? This one is epithalamus. So epithalamus, thalamus done, epithalamus, then the subthalamus. Now see, these are the names. This would be our style today. We'll talk about that, what's the importance, then we'll draw, right? So that we get a general idea, and then we'll start with the dissection. Then we'll go for the images, and with one by one the structure, right? Sub, right? Under. Subthalamus. So this is under the thalamus, its location, right? So it has got name subthalamic nuclei, right? Nuclei. Now we talked about that, yes, this basal ganglia is very important structure, right? Perhaps next time we'll be taking this basal ganglia, right? Very important. You know the thalamus and you know the basal ganglia, and the whole picture would be regarding the brain would be crystal clear, right? So this is the basal ganglia, and that basal ganglia will be talking with this subthalamic nuclei, right? So this is subthalamic nuclei. No doubt there will be pregeniculate, that perizonal, right? So many things will be there. But today, when it works with basal ganglia, what it will do? Movement regulation, right? It will lead to movement regulation, right? Fine controlled movement, all those things. Thank you, Shiv. All those things, they are with respect to this basal ganglia. So when we'll be discussing basal ganglia, at that point, once again, we'll come back to this subthalamic nuclei. Fine. And last but not the least, right, the all-time big boss, hypothalamus, right? Hypothalamus, carrying so many features, so many functions, right? So right from the endocrine to autonomic, to it controls the emotions, moods, right? All the awareness, then the hunger, all those things, homeostasis, all those things, they are handled by hypothalamus, because it controls so many areas. Because you know, hypothalamus will straight away be talking to pituitary, right? Pituitary. And in pituitary, adenohypophysis and neurohypophysis. In adenohypophysis, you have got all that big list, right? ACTH, LH, FSH, then growth hormone, right? All those things, they'll be coming into picture. TSH, then melanocyte stimulating hormone, they will be part of the adenohypophysis. And on this side, there would be antidiuretic and the oxytocin, right? So we have got the anterior pituitary and the posterior pituitary, anterior pituitary adenohypophysis and posterior pituitary neurohypophysis, right? But controller, hypothalamus. So endocrine, then autonomic nervous systems, and the emotions, need, emotions, hunger, right? Emotions, hunger, all those things, they are part and parcel of things which are handled by hypothalamus. Let's do one thing. We draw a sorry. Yeah. So we draw a rough diagram. This diagram will take us to the level that where exactly are the things associated. So let's draw, right? See the diencephalon, right? Diencephalon, you know that it's something like this, right? Optic recess, infundibular recess, then there was optic chiasma, then there is pituitary, right? All those things. But when we say it like this, right, this is the biggest and the largest, and that's thalamus. Okay, that's thalamus. So this in between is interthalamic adhesions. Right now, not writing. We just write four things that where exactly are these things situated. Then that pituitary gland, which would be posterior. So that would be the part of epithalamus. Right? This would be the part of epithalamus. Right? Then something which is just underneath. So that would be part of subthalamus. Subthalamus. And anteriorly and inferiorly, we have got the hypothalamus. All these things collectively, they are called as the diencephalon, right? So in hypothalamus, once we'll study the only hypothalamus, so that is where we'll see that, see very rightly, periventricular zone, the zone which is near the ventricles, surrounding the ventricles, right? Then there would be medial zone, right? There will be medial zone, there would be say lateral zone, right? Medial zone, lateral zone. So thus every epithalamus, subthalamus, thalamus, all are divided, but the division of thalamus, that is superb, right? Because it is having so many nuclei, right? Actually, it has got over 50 nuclei, and today we'll be studying quite a lot of them. But I'll give you the complete idea about how they are arranged, right? Okay, so chalo, let's start with this fresh brain, right? And we know this is cerebrum, and that's the parietal lobe, the frontal lobe, this is occipital lobe, and the temporal lobe. Yeah, you know that, right? So temporal lobe. Then that's the pons and the medulla oblongata, right? This is olfactory. This is olfactory. Olfactory now. What we do is just remove left half of cerebrum. So if you see, this is the cerebrum, right? We are watching from the side. This is anterior. So you are watching the left side. So left half of only cerebrum, right? We are not removing any of the structure. Remember, it is not so that we are removing left half of brain. No, only the cerebrum, right? So in fact, we can say we are removing left cerebrum. That would be more appropriate. Left cerebrum is removed, right? Only that we take off. And when we take it off, this is what we see, right? This is what we see. Now, what is that? Here, first thing first, starting with the easiest things first. This, cingulate gyrus, correct? Cingulate gyrus. Now both the halves, they are connected with each other, they talk with each other. So that one is sorry, this one is corpus callosum, right? Corpus callosum. The shape itself is telling, this entire shape, right? That itself is telling that we are dealing with lateral ventricle. Now, because this lateral ventricle is not our topic today, so very soon this lateral ventricle has to go, right? But there is something which is in the cavity, in the loop of this lateral ventricle. See how nicely designed, right? This one, then there is big one over here, and see how nicely they are connected, right? And then there is, it goes tail like this, there is something over here. All these are nothing but basal ganglia, right? These are basal ganglia. So this and this, these are nucleus, right? So this one This is C-shaped, so we say it caudate nucleus, right? This in between, right? It is mota sa with bada sa pet, so putamen, right? Putamen, right? But they are on both the sides. It is on the left as well as right. So we have to be specific. This is left caudate nucleus and this is left putamen. Collectively, they are part and parcel of the basal ganglia. So we'll remove them also, right? We'll remove the lateral ventricle also, right? And that's how we'll follow, right? Right now, I'm just writing it. Then see this area, this is hippocampus. Hippocampus, right? Very soon all of them, they will start coming up. Then rest is all easy. This one is cerebellum, right? This is cerebellum. Yeah, I'll show you, right? So this is cerebellum, and because see choroid plexus, once we have to remove this, then the choroid plexus will come. So just wait, it will come, right? So this is cerebellum, right? And rest is all pons and medulla oblongata. You know that that's the eyeball, lacrimal duct, all those cranial nerves, right? So this is the thing, and let's remove this, right? So what we have done in this case is we have removed basal ganglia, right? So caudate and putamen, they have been removed. So cingulate gyrus, you know very well. Now this is the lateral ventricle, right? This one, lateral ventricle. Still, this lateral ventricle, right? Over here, we have removed the lateral ventricle also, right? Over here, see, this entire extension. So basal ganglia removed, lateral ventricle removed. But then I'm telling lateral ventricle removed and I'm labeling it because now we are watching lateral ventricle of opposite side. This is the right lateral ventricle. This is the right lateral ventricle. We have removed the left lateral ventricle. Got it? Right. So that has been removed. And this is where we are coming and we are watching thalamus, right? That's the thalamus. Choroid plexus, that would be above, right? So even that structure, right? Let me see in some of, okay. Here is the choroid plexus, right? This one is choroid plexus. This one is choroid plexus, right side, right? Right side. So while removing, right, when we removed all the structures, right, all those structures, our purpose was to reach to thalamus. So rest of the structures whatsoever were coming in between, right, they were all removed. So if you really want to list what we removed lateral ventricle left, basal ganglia, we removed choroid plexus, right, all these things left side, that has been removed. Then we also removed that corpus callosum, right, because that corpus callosum is removed. Corpus callosum, that has been removed. Lateral ventricle, all those left hand side things, they are removed. Now we have the picture with us. Still there is one thing. Thalamus, we can see this one is cerebral peduncle, right? Cerebral peduncle. Cerebral peduncle is something what is connecting the cerebrum, right? Over here, along with, say, this one is pons, this one is medulla oblongata, right? So let's remove all these structures, midbrain, pons, medulla oblongata, even let's take a section of that also, right? So we remove that, and now is the picture what is needed. This is where pons is removed, medulla oblongata, that has also been sliced, right? So here is the right-sided lateral ventricle, right? Right-sided lateral ventricle, and then this one is thalamus. Thalamus. Zooming it, right? So thalamus. Then see this this one, right? That is substantia nigra, which will be part of midbrain, right? So this is substantia nigra. But interest is there is a nucleus just underneath it, that part, right? That one is subthalamic nucleus, right? That one is subthalamic nucleus. Then the third ventricle, right? See this one lateral, so this one would be the third ventricle. So I'll just write third. This one would be the fourth ventricle, so that is the fourth ventricle, right? The structure which is over here, that's what now we need to see it bit more properly, because there are so many things. They are so small, so that's why in subsequent images we'll start enlarging this area, right? Because here we can see that superior colliculus, inferior colliculus. Where was superior and inferior colliculus? Yes, we know that there was anterior commissure, then there was posterior commissure, right? It is going like, then there are fibers which will be going like this. Then we have got this. This is cerebral aqueduct of Sylvius. There was quadrageminal plate, and then there was superior colliculus, inferior colliculus, right? If you really want to see here it is, as such, seen very nicely, right? All I need to do is just remove this. See this one, right? This is superior colliculus, this one is inferior colliculus, and this one would be the trigeminal, quadrigeminal plate, right? Because this is cerebral aqueduct of Sylvius. But no worries, this colliculus, etc., they will be coming in superb detail, right? We'll be focusing only on them as they arrive. So ventricle is no more needed. We remove the ventricles also. So over here, ventricles gone, right? All ventricles gone. We have removed that. Now what we see is just the choroid plexus, which is lying over there, and this is the corpus callosum, right? This one is corpus callosum, right? Choroid plexus, and this is the thalamus, right? That's the thalamus. Remember, we are watching the right side, right? So all other things, they have been removed. So thalamus, then just below that was the substantia nigra. This is fine, substantia nigra, right? Over here, that is subthalamic nucleus, this posterior one, right? Because this is the pituitary, so that pituitary will be seen over here. But in this, let's not mess up, we see it in next one, right? So okay, so in this, right, see the anterior portion, right? What you have to remember is the anterior part, and this one is the posterior, right? So if we really want to divide the whole thing, this one, this which is just underneath, right, that is the medial nuclei of thalamus. So it means this thalamus is having multiple nuclei. Yes, you can say that thalamus is like a double-decker bus, right? Double-decker bus. So there'll be dorsal, there'll be ventral, and then on the posterior there would be pulvinar, and then there is an anterior group, and all the nuclei, they are in two layers, right? So this is what we'll draw and we'll see. But rest of the structures, they are quite okay. This one we can keep it for practice. This is taken at an angle, right? Just to know that when we say thalamus, right, here we see thalamus of both the sides. This is thalamus. right? Here also, this is thalamus, right? So both the thalamus, then they are connected with each other by interthalamic adhesions. See, this one is substantia nigra, this one, right? This one is substantia nigra, and near the substantia nigra, there is inside, you'll find the subthalamic nuclei. This is pineal gland. See this one. This is good, right? In the center, this one is pineal gland. Every structure will be watched multiple times. Pineal gland, part of, just a revision, part of epithalamus, correct? Another important part would be habenular nucleus, right? It will come. So now see, as we see this structure, right? Now what we do is, we saw it from the side, we see from the top. Time to time, we'll keep on discussing about it. When we see it from the top, it will give us that this is the location of the thalamus, right? This is the location, centrally located, They both are connected with each other by interthalamic adhesions. So thalamus would be like this, interthalamic adhesions. In between there would be third ventricle, right? In between there is third ventricle. What's the importance of this? The importance is that this third ventricle to fourth ventricle, this is the cerebral, right? Cerebral aqueduct, right? Aqueduct of Sylvius, very narrow, Sylvius. Now this area over here, there is thalamus, right? So what's opening? Interventricular foramen of Monro, that is also opening. So whenever there is any of the SOL, space occupying lesion, this area will compress it. Similarly, this thing can be compressed, aqueduct of Sylvius. This thing would lead to hydrocephalus, right? This thing can lead to, so space occupying lesion of thalamus would lead to raised intracranial tension, right? And that is, it will lead to hydrocephalus. No doubt there would be other signs symptoms also, because function of thalamus is the control. So if that control is lost, that is what is called as chorioathetosis, right? There would be uncoordinated involuntary movement, right? So it is because fine control, that is by thalamus. So now that is gone. So it will lead to this. No doubt there can be infarct, right? And we'll see the MRI of it. So this is the idea. This is what we see when we dissect from the top. This is the top view, right? This is the top view. And that's our thalamus, this one, right? That's the thalamus. Just give me a second. This one, right? This one is thalamus. And see, this is like exposing the full thalamus, right? So that's how the thalamus is on both the sides. Right? By the way, here is the pineal, right? That's the pineal gland, situated in the center, right? That's the pineal gland. Okay. Now, if this is thalamus, and we said that it is divided into, say, it has got 4 parts. Diencephalon has got 4 parts: thalamus, epithalamus, hypothalamus, and the subthalamus. Thalamus is, it's, if you really draw, its shape is like this. This is, right? It's like an egg-shaped thing. It's egg-shaped. But what would be the size? The size is just of the size of your one phalanx, right? Roughly about 1.5 inch. It's that small. egg shape, but it is that small. So this is the area which we are talking about. This is the area which we are talking about, right? Achha. Now, interthalamic adhesions, it is this, right? This one, right? That is interthalamic adhesions. So it is interthalamic adhesions. You can ask a question that why don't we call it interthalamic commissure? Because see, we said that commissure is what, where the fibers are going and coming and they are communicating, right? But over here regarding this interthalamic adhesions, there is so much of debate about whether the fibers really communicate with the opposite side. So that's why it is temporarily it is called as the interthalamic adhesions, not commissure, because fibers which are going, right, on the opposite side, are they really say carrying the impulses from one side to other side, or they are functioning independently? There is so much of debate. So that's why it is called adhesions, right? So that is interthalamic adhesions. Now we talk about, say, internal structure. Now starts the real part. So we know that from brainstem things go to thalamus, and thalamus is like a relay center, controls, modifies, right? And finally it sends the finished product, right? Finished signals to cerebral cortex, and then cerebral cortex distributes it to specific area as per the need. So it has got so many. Now when we say gray matter, right, when we say gray matter, immediately you will say gray matter consists of, yes, gray matter, G, right, curved, it consists of body, it consists of body of nuclei, right? And when it comes to white matter, right, straight lines, so straight lines, so white matter will be consisting of axons, right? So this means this is body, and we know that this body is nothing but it is like our CPU, it is like our processor, right? So it is like in neuron. So this is the body, that's where the processing occurs. Axons, they are like wires, they are for the transmission, right? So they just transmit, this processing is done over here. That's, and when multiple such bodies they unite, they lead to formation of nuclei, right? So that is the why gray matter, and that's why we have got nuclei over here. Yes, obviously there'll be some areas, there'll be some white matter also. It has to be there now, because when the axons will be going in bundles, so that will be leading to formation of white matter, because see, these are the wires, right? When these wires go, so this portion would be the white matter, right? Because they will be axons. Tick, axons. So in internal structure, right? In the internal structure, the nuclei, they are divided into several groups. Easy. Why? There would be one Y-shaped band, right? Y-shaped band. Everything has got a name, but it will divide this into anterior group, then there would be medial group, and then there will be lateral group. Lateral group. So these are the groups which will be divided like this. Here is it, right? This Y-shaped, right? This Y-shaped. So here we are watching of both the sides, right? So if I really draw it like this, it would be like, this is one thalamus, this would be second thalamus, then they are interthalamic adhesions. This is one Y and this one is second Y. That's how they are, right? and then we say this as the anterior group. This one obviously would be the medial group. This one would be the lateral group. This is the anterior. This is medial. This is lateral. Makes sense? Complete? Fine. So if we really want to draw, so we'll say this one would be the anterior, right? This one would be the anterior group of nuclei. This one is also anterior. This one is lateral, and this one would be medial. Thick, medial. So less space. This fine. Medial. This is lateral, and that's anterior. To make it still more clear, let's take it on another page. This Y-shaped band, right? This one, this Y-shaped band, Y-shaped band, it has got a name. First, nuclei, they were gray matter, right? So this Y-shaped band, first, it is the white matter, right? It is white matter. See how systematically everything is connected. So white matter, they are like axons, and everyone's head is inside. So they are processing and then sending the signals, right? This Y-shaped white matter is called as the medial medullary lamina. Lamina means sheath, right? So it is called as the medial medullary lamina. So easiest explanation, Y-shaped, this is medial medullary lamina, and then we have got anterior, medial, and the lateral group of nuclei. Now this is like high processor equipment, so it has to be covered, right? So when it will be covered, there will be sheaths. Lamina means sheath, right? Lamina means sheath, something which is covering it, right? In the form of bands. So over here, this is when we say medullary lamina, it is also known as, right? This is AKA also known as internal medullary lamina, right? This is internal medullary lamina. So that's our Y-shaped structure. This is internal. For the external, that what would be covering it, right? Now we are talking about the external landmarks or external features of thalamus, right? We are watching two thalamus together, right? This is left and right, both the thalamus. So covering it, right? If on the lateral aspect, right? So this one would be the lateral aspect. This one would be the lateral aspect. So on lateral aspect, there is something which is covering, right? On the lateral aspect. This lateral aspect sheath which is covering, that is called as external medullary lamina, right? So this is, that one was internal, right? That Y-shaped, and this is external medullary lamina, external medullary sheath. This is external, right? And yes, on lateral side, on lateral aspect. Well, this was easy. There is something which is covering on the top also, right? Covering on the top. So over here, this top is dorsal, right? In this, remember this, top is dorsal and floor is ventral. So when we say there is a covering, there is covering on the dorsal aspect, so that means this is on the top. This top, will it be white matter or gray matter? It has to be white matter, right? Because the gray matter is consist of cell bodies and all those things, they are processing inside. So processor is inside. These are the coverings, right? These are the coverings which are made up of those axons. White matter, they are taking the things to next level. So this is white matter. No, because we have removed the external, right? That's why we were just to see it properly. But otherwise, this Y-shaped band, that is again covered, right? So that's why for the clarity, I'm drawing everything like this. So Y is not present externally, Y is present internally. That's why it is also called as internal medullary lamina. Got it? And on top, this is white matter, right? This is white matter, and that white matter is called as stratum, stratum zonale, stratum zonale, right? And that's how it is wrapped up, right? So we have got the external and the internal features. Our next purpose is when we drew, right? When we drew this a Y-shaped, right? Now we'll not be talking about that that external part, right? Now we'll be focusing on internal. So this is anterior, right? This one is medial, this one is lateral, and this is the Y band, and Y band is internal medullary layer, right? Or the sheath. Posterior part, right? So for that, we need to make a small change. The posterior part, now it is like this, right? This is called as the pulvinar. Pulvinar. This is posteriorly situated. So pulvinar is what? Pulvinar is posterior extension of thalamus, right? It is posterior extension of thalamus. Can we see it? We can, right? We can, because so easy to figure out. If this is the thalamus, right? If this is the thalamus, this is anterior, this is posterior. Posterior of thalamus, this one is pulvinar. This one. That one is pulvinar. Fine. So this pulvinar of thalamus posteriorly situated, and pulvinar the function of thalamus is for integration, right? Now see, there are some very important structures over here. See this one, right? This one, very important structures. So obviously one who is near, they'll be talking to him, right? These are all what, right? You remember superior colliculus, inferior colliculus, they are here. This is this one, this one, this one, right? So this above is pineal gland, right? Then we have got superior colliculus, and then we have got inferior colliculus, right? So superior colliculus, which is for vision, inferior colliculus, which is for audio, right? The hearing, right? So pulvinar is what is present over here, right? So this is also superior colliculus and inferior colliculus. So pulvinar is for integration of vision, hearing, right? Then pain and various sensations, right? So that's the function of pulvinar. The next over here, orient yourself. Now we have zoomed that part, right? So it's only this portion. It's the only this much portion will now be focusing on, right? So and we are tilting it. So as we watch, this is more or less like a posterior view, right? We are watching it from behind, and let's orient ourselves very properly. So that's like cerebellum, right? This is that pons, medulla oblongata, right? That's what we are watching. This is our pineal gland. This is our pineal gland, right? Seen very clearly. The next one over here, here and here, right? That one would be, you're right, superior and inferior colliculus. But now see how the relays start. Can you find out, can you see that there is one structure over here, the bulge, and then there is one structure over here, right? That is called as the geniculate nucleus. So one is medial, second is lateral. So here it is medial and this one is lateral. Geniculate nucleus. Medial geniculate nucleus, lateral geniculate nucleus. That's how they are situated, right? So what will they be doing? This medial geniculate nucleus, that will be relaying to inferior colliculus. And inferior colliculus is doing what? It is for the audio. It is for the hearing, right? That is medial geniculate. Remember this relation, medial geniculate to inferior colliculus, and it will be handling auditory path. That's right. They come as medial and lateral geniculate bodies. That's right. Right. And similarly over here, right? Same thing. But this time, say over here, we saw that medial geniculate, and if we just focus on this one would be the lateral geniculate, right? So that is the lateral geniculate body, and inside we have got the nucleus. The body is formed because of the bulge, right? And that bulge is due to because there is a nucleus present inside. So this one, lateral geniculate, right? Lateral geniculate body or the nucleus, that will lead to superior colliculus, and superior colliculus will be handling the vision, right? So this is like, they are like relay stations, right? Medial geniculate and the lateral geniculate, they are like relay stations. They handle. Achha. One point, cerebral aqueduct of Sylvius. Then there was superior colliculus, inferior colliculus, right? So over here there was quadrigeminal plate, right? Just this is quadrigeminal plate. And then this one was cerebral aqueduct of Sylvius. So cerebral aqueduct of Sylvius. True. As we are talking about this, so I think we can write it here. Lateral geniculate body, right? So medial and the lateral geniculate body, collectively, it is called as metathalamus, right? It is called as metathalamus. So collectively called as metathalamus. Let's see where exactly was that stria medullaris, right? We talked about this stria medullaris. First, we'll just talk about it and then we'll draw. Stria medullaris, right? It is again like a tract. It is again like a sheath. So it has to be white matter. white matter, because it is not nucleus. So it is white matter. When it is white matter, that means it's a tract. Yes, it's a tract. It's not a thick tract, it is a thin tract. Yes, it has to be a thin tract because structures are so delicate, very less space is available, right? This is from anterior to posterior. Okay, so this would be anterior and this one would be posterior. So it is going from anterior to posterior. This would be the direction. Okay. In that case, anteriorly, what do we get? Anteriorly, we get the anterior commissure. So where is anterior commissure? Here is anterior commissure, right? So we have got anterior commissure. Okay. But one more thing it is there over here, right? That is what? Hypothalamus. Okay. Right? So that is hypothalamus. So when the track is going all the way from anterior to posterior, so it will take it, chalo, anterior commissure, hypothalamus. I'll carry your signals also. And there starts from here the stria medullaris. Now this stria medullaris, it should go on the back side, posterior, right? So posteriorly, it is landing on, we have posterior commissure and the habenular commissure, right? On the posterior aspect. So on the posterior aspect, it lands into habenular trigon. Trigon means area. This is like a trigon, right? This habenular trigon, which will be having habenular commissure as well as habenular nucleus, and this is part of epithalamus, right? So this is epithalamus. Now, is it coming properly? Let's see, this is hypothalamus. Hypothalamus is communicating to epithalamus via stria medullaris, right? Via stria medullaris. So that's the stria medullaris. Anteriorly, we have got the anterior commissure, hypothalamus, and it is traveling. Now let's if you really want to find out that where exactly it travels, let's draw it, right? Within 1 second, you will come to know. This is why. If I say that it will be traveling between on the border of medial and superior surface. So now clear, medial and superior surface. So there is a superior surface, there is a medial surface, and in between it is traveling, right? In between. So if we really pick up any of this image, if we really pick up this image, right? This is where it will be traveling. This is, right? So between the superior and medial. So if we really will watch from the back, so if this is the superior, this is the medial, so this is the point. That's how it will be traveling. Okay. So this stria medullaris is traveling between superior and medial surface of thalamus. Now we need to see this habenular part, right? Where exactly this habenular zone or habenular trigon, habenular zone. This habenular is near the pineal gland, right? See, in this we have seen this. This is what, this is the pineal gland, correct? And above the pineal gland, that was habenular commissure. Here is the pineal gland. Here is the pineal gland. And you must have known, this is habenular, that one. That's the habenular trigon, right? So here it is, this one. And this will be having nuclei and commissure both, right? So we have got H nuclei, that is habenullar nuclei, and habenullar commissure. When we say commissure, do remember it is communicating with the opposite side, right? So for communication with opposite side, right? So that's how the stria medullaris is landing over here. So this would be the destination for stria medullaris, which is coming all the way from anterior aspect, right? To two aspect, anterior commissure and the hypothalamus. Fine. This is pineal gland, right? You now know it about it well. This is pineal gland, and pineal gland is having important endocrine function, right? Endocrine function. Very important for sleep, right? Very important for circadian rhythm. Circadian rhythm. One very interesting question which was asked that before some time I talked about that you should really know your circadian rhythm very well, right? That what is the best time when your energy level is high. One email was that my best time is from night 11 o'clock to 2 o'clock in the morning. So should I study every day during that time only? Is it okay? Well, sleep is important, but if you really study at that time and if you feel that that is the best time, but then when will you sleep? So that is also equally important. So yes, circadian rhythm, it can be changed, right? Gradually it can be changed. If you are late riser, every morning, right, you just adjust 5 minutes, 10 minutes, 5 minutes, 10 minutes, right? Be comfortable. After 1 week you'll find that automatically you'll start waking up early by 10 minutes. Then next week once again you make small change, so that would be helpful. So pineal gland is for that sleep and circadian rhythm, and releases and secretes melatonin. Melatonin, right? That is for it. Okay. So we talked about, say, geniculate bodies, right? As it is seen over here, so we are this one and this one. This is superior and this one is inferior colliculus, right? Inferior colliculus, because here they are seen so clearly. And classically, the pineal gland is present between two lobes of superior colliculus, right? So this is pineal gland. Pineal gland. Between two superior colliculus. So this is how things are arranged, right? So now you know very well about superior colliculus, inferior colliculus, quadrigeminal plate, lateral and medial geniculate bodies. We go for some schematic diagram, right? And those schematic diagrams will make your concept still more clear. In a way, egg-shaped thalamus, another egg-shaped thalamus. Connect both of them by interthalamic adhesions, right? So in between, what would be there? In between, it would be third ventricle, right? Third ventricle, because that is what is in between, right? And these are the Y-shaped band, Y-shaped band. This one would be anterior, this one is medial group, this one will be lateral group, right? Then surrounding it externally, right? Externally, we have that external medullary lamina, because this one was the internal medullary lamina or sheath, and this one is external medullary lamina. And then something which was covering it on the dorsal aspect. So, right, like this, we draw it. So, we call this thing as stratum zonale, right? So, it is stratum zonale. Same thing on opposite side. But because we need to add something over here, and that one would be pulvinar. Pulvinar is posterior, this is anterior, this one is posterior, right? And on top of it, we were having something more, so that's pulvinar. 1, 2. They were what? They were geniculate bodies, right? So this is lateral geniculate body, this one. Lateral geniculate body was going for lateral will go for vision, right? So lateral geniculate body will go for superior colliculus. So it will go for superior colliculus, and that one is for the vision, right? Well, this one, right? That is inferior geniculate body, medial geniculate body. So this is medial geniculate body. That one is meant for inferior colliculus, right? And inferior colliculus is for audio or the hearing. Right? Though we have discussed it, but did it again. Achha. Outside it, right? Outside this, over here, there would be basal ganglia. And then still outside, there would be cerebral cortex. Right? So from externally, when we try to go inside, this is the order in which things will come. Optic chiasma end up in lateral geniculate. Yeah, that's right. It will. So the cerebral cortex, basal ganglia, and in basal ganglia, we have so many nuclei, right? There would be caudate, there would be putamen, globus pallidus, right? All those things. Then there would be internal capsule which will be separating them. So that entire structure is outside, right? We go into slightly depth of all these nuclei. Right? This is thalamus. Think it like this is interthalamic adhesions, right? Interthalamic adhesion. We divide it into two parts. This one would be medial, and below it would be lateral. This is posterior, so we just put it like pulvinar, right? So this one would be lateral. Right? Divide again, Y-shaped band, so this one would be anterior, right? So things are now much clear, medial, lateral. But there is one thing. This above is called as the dorsal, and below it is called as the ventral, right? This is called as the ventral. So this is once again divided, right? So now this lateral, let's be specific. Both are lateral. One is lateral dorsal, so LD, lateral dorsal, and another is lateral posterior, right? Lateral posterior. So they will be lovingly called as LD and LP, right? Lateral dorsal and lateral posterior. While this ventral, right? Ventral would be divided like ventral anterior, ventral posterior, and in between, right? It is ventral lateral, right? So these are the grossly. Then once again, this VP, ventroposterior, will be divided into ventroposterolateral and ventroposteromedial, right? I just write it down, ventroposteromedial and ventroposterolateral. So overall, these are the things. Then we should add those two, right? The geniculate body, right? So that's the medial geniculate body and the lateral geniculate body, right? And then they will be connecting to. Medial will be to inferior colliculus, right? And this one will be to superior colliculus, right? This is for audio, this is for video. I mean hearing and vision. Okay, so do remember this part. The dorsal is sky, right? Dorsal is roof, ventral is floor. Now when it comes to, say, their functions, right? What exactly they do, we try to understand it in the, yeah, now it is okay, right? This one. So anterior, this will be connected to emotions and memory. That's the reason that in case if anything goes wrong to thalamus, right, the memory is affected, emotions are affected, the personality changes, right? So this is connected to limbic system, which is related to emotions and memory, right? When it comes to medial part, now in this there is medial dorsal, medial ventral. Once again, they are connected, but its main function is for the integration of somatic and visceral efferent. Again, emotions, they are definitely handled, plus the hypothalamus is also involved, right? So very important integration, right? So very important integration of, say, somatic and visceral, plus hypothalamus is involved, right? That is the part of the medial. If I divide this into two parts and we say that this is lateral dorsal and this is lateral posterior, right? Lateral dorsal and lateral posterior. And this one, this entire portion, this one is the ventral one. So ventro anterior and then the ventro posterior and the ventro lateral. This ventro anterior and ventro posterior, see how wonderfully it makes the whole sense. This is connected to, ventro posterior is connected to, the moment I'll write, you will say ha, right? In every time that there is some like aha factor. Can you label all the nuclei from a top view aspect? This is, in fact, we are doing that only, right? This one. Achha. Coming to this ventro-posterior. Ventro-posterior is what? Ventro-posterior will be connecting to primary somatosensory, right? Primary somatosensory. So when it is primary somatosensory, this is area 3, 1, 2, right? This VA, ventero-anterior, is connected to motor cortex, area 4, right? Even some part of the ventrolateral, right? That can also be connected to motor cortex, but this ventrolateral, primarily it will be going to cerebellum, right? And red nucleus, which is into the midbrain. But this is how. And pulvinar, right? Pulvinar, we talked about that audio, video, pain, right? So vision, hearing, pain. So that's how they are grossly connected. Apart from this, two things which we have to add, but we are not writing it over here because we have talked about it, just the medial geniculate body, right? And the lateral geniculate body, right? This is inferior colliculus, and that is for audio. And this lateral geniculate body is with superior colliculus and that is for the video. Right? Now let's talk about some tracts, all these tracts. We are dealing with now ascending tracts. Ascending tracts means they are coming from spine, right? So from spine to thalamus, so very rightly said, spinothalamic, spine to thalamus, right? And there are two. One is lateral, one is ventral. Right? These are two. Lateral will be carrying pain and temperature. Because see, they are coming from the spine, right? And from spine, all those spinal nerves were going. Those nerves were reaching to distant places, and from there, the receptors, they were sending the signals. They came to spinal nerves. From there, it entered into spinal cord. From spinal cord, right? All of them, that bundle, that conduit of wires, they are going up. And this wire group, spinothalamic, lateral spinothalamic, is carrying pain and temperature. Right. Similarly, ventral spinothalamic tract, that will be for crude touch and pressure. Right. This is this touch, crude touch. Crude touch is when the hand is held like this with power. That is a crude touch. Right. Then the pressure. So crude touch and pressure, that is what is handled by this ventral spinothalamic. Right. And this is very specific. This crude touch and pressure, that ventro-posterior, we saw ventro-posterior. This ventro-posterior is actually divided into two parts, ventro-posterior medial and ventro-posterior lateral, right? It is divided into two parts because this is going for this primary somatosensory. So this particular feeling of crude touch and pressure is by VPL, ventro-posterior lateral, right? There is just one more important track, or in fact it is like a whole path in the dorsal column, right? It is called as the dorsal column to this medial lemniscus. We have not yet talked about medial lemniscus, etc. So just keep in mind that this is one particular tract, but its function is very important. That's why I put it over here. The function is proprioception. Proprioception is that even if you close your eyes, you know that what exactly is your body, in which position it is, right? So it is that sense, that is what is the sense of joint position, right? The sense of joint position. This is one. And second, the vibration sense, the sense of vibration, right? Vibration sense, that is by this particular pathway. So, for the clinical understanding, we need to know about the arterial supply. Very simple, right? It's pretty simple. So we know this is like vertebral, right? Vertebral, both the vertebrals, right and left, right? They form the basilar, right? This basilar would split into, say, posterior cerebral artery, right? Posterior cerebral artery, and then on top we have that internal carotid, right? That internal carotid will be having, say, middle cerebral artery, and then anterior cerebral artery will go up, right? There would be one more branch which will be connecting over here. We are interested in this branch. This is posterior communicating, right? This is posterior communicating artery. So now we change the color. It is the posterior cerebral artery, right? Posterior cerebral artery which will be supplying to thalamus, and the branches from posterior communicating artery which will be supplying to thalamus, right? To thalamus. So over here, so if we say arterial supply, one is by posterior cerebral and second by posterior communicating arteries, right? So that's the blood supply of the thalamus. So when we talk about the clinical part, right? Clinical part. Just wait, let me see if I put, yeah, it is there, right? So clinical part, two things we have to remember, that it is called as the SOL, space occupying lesion. When it comes to brain, whenever you are studying the neurology, two things can happen. One, if the circuit is disturbed, then that will lead to some specific symptoms. And if it is compressing something, so then there would be another set of specific symptoms, right? So over here, the thalamus part, right? Thalamus. If we say that, okay, this is the anterior part, right? Anterior part. If there is any SOL over here, so anterior part, that is very near from both the lateral ventricles, right? They are coming down, so there is interventricular foramen of Monro. So in such cases, interventricular foramen of Monro, right, that would be vulnerable and it can get obstructed. So this is obstruction is a possibility. When it comes to posteromedial, right, remember posteromedial, because that the third ventricle, that was just on the medial aspect. So medial wall, right, medial wall of both the thalamus, medial wall of both the thalamus is in fact forming the lateral wall of third ventricle, right, and in between the interthalamic adhesions they are going, right? Am I right? See, this is thalamus, in between interthalamic adhesions, and here is the third ventricle, right? That's the third ventricle. So any of the lesion, space occupying lesion, is going to obstruct it, right? And still more important, something which is so delicate, as it goes down to that third ventricle and that cerebral aqueduct of Sylvius, so as such it is so small, right? So when it is posteromedial SOL, so third ventricle can be affected, plus cerebral aqueduct of Sylvius, it can be affected. What will happen in such cases? Well, the CSF circulation will be hampered. Reason? Those choroid plexus, they are constantly making the CSF, right? So here there would be increased intracranial tension. That would lead to, this is hydrocephalus. Right? And then there would be all the symptoms of hydrocephalus. Now, apart from that, the thalamus is very sensitive. So any insult to thalamus in the form of, let's say, ischemia is not getting enough blood. Right? Now it could be due to several reasons. It could be some accident, it could be iatrogenic, maybe because of some drugs, because of some surgery, right? So whether it is iatrogenic or it is due to some hemorrhage, right? It is due to some hemorrhage, or it can be due to, say, thrombosis, right? So what is called as the thrombotic, anything. When there is involvement of ventroposterior, right, medial and ventroposterior lateral, primary somatosensory, right? So there would be contralateral, that is opposite side sensory input, right, that is affected or that is even lost, right? There is a concept of thalamic pain, right? Thalamus is handling pain, but when there is infarct, right, whenever there is infarction, we'll see a case of infarct, right, just in few minutes. When there is thalamic infarct, so then thalamus overreacts to pain signals, right? It would overreact to these pain signals. So even if it is like a feather, it would look like a hammer, right? So overreacts to pain signals, even the weak pain signals, and person would shout, right? So this is commonly because of thalamic infarct. Now, when this is affected, we know that thalamus is for coordination and the proper regular movements. When there is infarct, this is a technical term, it is called as the ataxic chorioathetosis, right? It is called as chorioathetosis. So what's that? This means there would be uncoordinated, right? Uncoordinated movements plus involuntary, right? Involuntary moves or the movements. This is what can really occur. Achha. Here is, say in MRI, whenever we see MRI, right? By the way, when we are dealing with any of the blood supply, blood condition, right? Blood insults in the form of hemorrhage or infarct. Even the PAT scan is also quite useful. Even the SPECT is also quite useful. Right? In MRI, there are two, these T1 and T2 weighted images. So T1 and T2 weighted images, they are excellent when combined, right? It is one of the excellent thing to figure out that what's the condition. For that, we need to understand the mechanism of how the images are formed in the MRI. When we say axial plane, so that's fine, means in which axis it is taken. But important is T1 weighted and the T2 weighted images. So this is the technique. And why I'm telling is because you will find that the same infarct, right? Same infarct in T1, it would look dark, and same infarct in T2, it would look bright. Right? So it's like because of the technique, right, in which the magnetism is imposed, right? And as the atoms they are changing, and then when they start releasing the energy, that energy is captured by the scanners, and then by the Fourier analysis it is converted into picture. So this is like a timing difference, right? What exactly happens? So when we'll be discussing at length only the MRI principles, things will be more clear. But let's see the case today. So this is MRI, and this one is axial T1 weighted, and this one is T2 weighted. See this area. Same over here. Right? This is infarction in the left thalamus, right? This is infarction in left thalamus. Still, if you really want to see it in much better way, then there is what is called as the SPECT, right? Single photon emission computerized tomography, right? That is for vascular or for vascularity. Okay, so this was for today. Right? Thank you so much. And I put the question that the evening hours are better for our further trainings, or should we continue with the morning? Because almost 80% came in the form of evening hours. Okay, we'll see to that, right? If the evening hours are more comfortable, so we'll take care. Okay, I'm putting this file into our folder, and see you next time. Take care. Bye-bye. What explanation you want? Because this one figure will tell everything. This just one figure you draw and it will tell you everything. See, this is the Y band. That's the Y band. This one is Y band. Don't worry about the external, right? That is not dividing the nucleus. So this is the Y band. We have got the anterior, medial, and posterior is pulvinar. And do remember that medial is roof, that is dorsal, and floor is ventral. So this is the floor, right? This one is floor. So all of them now they are starting with ventral. So ventroposterior, ventroanterior, ventrolateral, right? And the medial part, which is into the dorsal side, that is the roof. So here it is arranged exactly. This is anterior part, this is the posterior part, because posterior has got, right, medial geniculate body and lateral geniculate body, correct? They are the posterior, and we have on the roof we have got this medial, and it is like a double decker bus, right? Double decker bus. So that is the double decker bus, this upper one and the lower one, right? And then rest with how they are connected, right? The same thing written over here. Important is this ventroposterior, that is for somatosensory, and ventroanterior, that is for the motor cortex, right? Okay, so that was for today. Do revise this thing properly, because it is very easy to forget this thing. So do revise it, right? Just those few images, right? Those few images, try to label it, try to draw those nuclei, and try to visualize. Next time also, that when we'll be taking the basal ganglia, we'll once again start it like that. But that time what would happen is, the moment we'll remove the cerebral cortex, immediately the basal ganglia will come, and then their structure, how they are connected. But then we'll be having external capsule, right? Then there'll be internal capsule, right? And then the parts of those internal capsule, then those basal ganglia, what are they called, right, collectively? So that's the thing, because once again those basal ganglia, if we remove, we'll come across this diencephalon. In diencephalon, there is thalamus, then there is subthalamus, right? Then hypothalamus below. Hypothalamus itself would be a big topic where we'll be going into the depth of, but it will be more towards the physiology, right? Because adeno and it controls adenohypophysis and the neurohypophysis. So that's how things would really go. Entire structure will become so easy to relish once you know this much, because when the tracts would come, you will know that okay, it should go like this only. So even in basal ganglia, we'll be discussing about the tracts, the way we discussed about those tracts. So when it will come to spine, all I have to do is I have to just tell you that this particular tract, this is the location of this particular tract over here. Rest would be easy to you, because tracts are in the form of ascending tracts and the descending tracts. When we are talking about thalamus, right, from the spinothalamic, from spine to thalamus, and from thalamus things are going to cerebral cortex, right? It is then cerebral cortex who will be sending the descending tracts to the spine. From the spine it will go to spinal nerves and to the rest of the body, right? So this is spine, this is thalamus, right? And this is where the final controls all are prepared, and then it will go to cerebral cortex, and then the descending tracts. So these are the descending tracts, and these are the ascending tracts. Okay, so thank you so much. See you next time, and putting this file into our folder. Thank you, and bye bye.